We're going to look at trigonometric functions and how to graph that, okay, using the parent functions. Okay, let's start from the sine x and the cos x. Okay, so but in the course of this class, I'm going to focus on graph of one period. Okay, so and I'm going to consider the domain to be from 0 to 2 pi. Okay, irrespective of the function, domain here gonna be 0 to 2 pi. Okay, so let's start with y equals sine x. Okay, so for graph of y equals sine x, this is what we have for that. Okay, this is what we have for y equals sine x. So just note that for sine function starts from the what midline. Okay, and you're gonna have maximum here to be 1 and minimum to be 1 minus 1, which implies that the range of this is minus 1 to what? Minus 1 to 1. Okay, so this is for sine x. Okay, so what if you now have y equals minus sine x? Okay, y equals minus sine x is just like reflection of sine x and on x-axis, and the graph of that we're gonna looks like this. That looks like this. What we're gonna have for that, so this is for y equals sine x. Okay, so this is y equals sine x, and when you look at this, you can see for sine x that starts from midline, then to maximum, midline, then to minimum. So for minus sine x from midline, that moves towards to minimum, then midline, then towards to maximum. You understand? So and the period here is 2 pi. Period here is 2 pi. So that is for sine x and minus sine x. So the two are reflection along what x-axis. Okay, so let's consider cos x now. Okay, for y equals cos x, so we consider domain to be 0 to 2 pi. Don't forget, I told you from the beginning that for the course of this lesson, I'm going to focus on the graph of one period. Okay, and mind you, normally this shape keeps on going forever in both directions. Okay, but because we only consider the range to be 0 to 2 pi, the domain to be from 0 to 2 pi, which is one period, so that's why we have something like this. Okay, so for cos x from parent function, that looks like this. For cos x, that's going to start from maximum, then to midline, like this. So this is a graph of cos x. Okay, and here we have maximum here is 1, the minimum here is minus 1, and of course this point is also what? 2 pi. Okay, so which implies that the range here, the range of cos x is minus 1 to what? 1. Okay, so what of y equals minus cos x? So which is the reflection of cos x? Y equals minus cos x. You can see for cos x, that starts from maximum. For minus cos x now, that's going to start from where? From minimum. And we're going to have something like this. So this is the graph of minus cos x. So the green one is for minus cos x, while the black one is for what? Cos x. So you have the same domain and range for that. Another thing you should note here is that for you to plot the graph, you need to get the maximum value. You need to know your maximum value, minimum value, midline, likewise period. Okay, so these are the 4 important things you need to know whenever you're asked to graph what's it called, trigonometric function. So let me just, okay, maximum, minimum, midline, and period. So don't worry, I will explain more on this later. Okay, yeah, so these are the parent functions for cos and sine x and their reflections along x-axis. Okay, yeah, so let's consider formula of this form. We have y equals a sine, this is for sine, I'm considering sine function, bx plus c then plus z. plus z. Okay, so a here is amplitude, and that's what I'm gonna consider for now. So b here, we use this one to determine period, but so let us focus on amplitude for now. So let's take, for instance, you have example, let's say y equals 2 sine x. So for 2 sine x now, something like this now, the coefficient of sine here is 2, which implies your amplitude here is what? Is 2. Okay, so if amplitude is 2, that implies that the maximum is 2. Likewise, minimum is what? Minimum is minus 2. Okay, so looking at this now, so what will be the graph of 2 sine x? That's gonna be this. Gonna have something like this. Okay, so we are display, and so which implies that the range of this given function gonna be minus 2 to 2, unlike the previous one where the range was minus 1 to 1. Okay, and for this we said the period is 2 pi because we consider domain from 0 to 2 pi. And what this means is that here is 2 pi, this place is pi, this place is 3 pi over 2, this place is pi over 2, while this place is what? Is pi. So we have this here. Okay, so I will use this one to consider y equals minus 2 sine x. So let's say we have y to be minus 2 sine x. So same thing, we're gonna have something like this. This is what we're gonna have for that. Sorry, I think I can make this better than this. Okay, so this is for y equals minus sine x. Okay, so now let's consider example on cos x. Okay, consider y to be 3 cos x. Yeah, so for something like this now, amplitude is 3, we have period to be 2 pi. Okay, domain is from 0 to 2 pi, and likewise range now, range gonna be minus 3 to 3. All right, so, and you should note that your amplitude cannot be negative, it should surely be positive at all times. Okay, now for cos, we have it here that maximum value here is 3, minimum is minus 3, and of course that cos starts somewhere from maximum. So we're gonna have this. As a, I think we can make this better. Okay, so this is what we're gonna have for cos x. Okay, for 3 cos x. Then let's consider minus 3 cos x. For minus 3 cos x, we're gonna have something like this. For minus 3 cos x. Okay, can you see the difference now? So, and the period here, this is 2 pi, so this place here is pi, this is pi over 2, while this place here is 3 pi over 2. Okay, so these are examples of cos x and sine x. Okay, so in next class we're going to consider how to determine period of function. Using this formula, we have vertical shifts, likewise we have horizontal shifts. So these are the things we're going to consider in next class. So if you are just joining us for the first time, kindly click on the subscription bell so that you'll be notified whenever I release a new video. Thank you. But before that, I will advise you to solve this, to sketch this following function: minus 4 sine x y equals 5 cos x. Ensure you do that So you consider domain of each of these to be from 0 to 2 pi. All right, thank you.